on the internet daunting, especially from the data analysis perspective. So having too much information is as bad as having none at all. So it's essential to propose automatic and intelligent tools to generate relevant information about large volumes of data. So in our research domain, what would be the big research challenge? We have one question. How should we propose new automatic and intelligent tools to generate relevant information about large volumes of data? One of the scenarios most impacted by the increase in data generation is science. And in 2014, an estimate was made on Google Scholar, and it was concluded that there were around 160 million documents in its base. Evidently, since the beginning of 2020, there has been an increase in articles on COVID-19. And furthermore, when it comes to the volume of data, there is an increase in complexity in the data analysis. The vastness of scientific work and research also makes several analyses difficult, such as identifying promising research areas or novel approaches and even possible collaborations between researchers. In this article, we proposed a general framework of automated steps for extracting relevant information about scientific articles. In the context of scientific research, the framework helps to answer several research questions, such as which authors contribute the most to a certain topic, or which lines of research are most explored by researchers at an institution, which countries lead research in a given area, and which topics are most explored by given author. The proposed framework was tested under a dataset made available by Kaggle in partnership with the Allen Institute for AI and other companies, foundations, and institutions. And its contents are articles on COVID-19, SARS-CoV-2, and other coronavirus. The first few records of work are from the early of 2000s. However, we kept a part of the dataset in this article, only those published in 2020, since it coincided with the pandemic's beginning and corresponded to the most significant number of articles. In addition, because it's a multilingual dataset, we prioritized articles in English only, which brought us a total of 26,000 articles. Our framework consists of 4 steps. So we have pre-process, topic modeling, correlation of topics to authors, institution, countries, and results visualization. The pre-processing stage seeks to ensure the item's consistency, removing possible noise and standardizing the data for later stages. So we have 5 sub-steps performed. We have conversion to lowercase of all characters, removal of top words, tokenization, removing entities for in ER, and construction of a bag of words as a M by N matrix. Topic modeling. This step seeks to find out the main themes discussed in the considered article or what topics they represent. So several techniques can be used, but the quality and results obtained in other works lead us to use the NMF approach. It decomposes our matrix I, or our matrix A, or our bag of words M by N, into 2 other matrices, W and H. Here we have the equation, where the value of k conceptually represents the number of topics, which is the factor that approximates the product between W and H for the matrix A. Here we have our bow, our matrix A, decomposed into 2 matrices, W and H, where H represents the article by topics, and W represents the article by topics, and H represents the topics by words. We know which documents are closest to a given topic and which words in our dataset make up a topic. So we basically know who wrote the paper, where the author works, and where the institutor is located. In this step, we extended the proximity values that an article has for a topic to the author, their institution, and their country which each institution are. Some mathematical considerations are performed in order to ensure fairness in the comparison performance. Oh, I have some problem with the audio returning. Can you turn off your microphone, please? Okay, thank you. The extension allows us to calculate for each entity, author, institution, or country, distribution of each research across topics, and also evaluate which entities have articles more aligned with a given topic. Summarization interface. This step gathers the data produced by the previous step and the raw data from the dataset and allows the visualization of it. So we have a web application that allows several interactions, such as searching for considered articles or using one of our visual metaphors for the correlations made in the previous step. The same result can be analyzed in different ways, bringing new perspective and insights to the user. Here, an example of our interface with a wide range of possibilities, various interactions, visual metaphors for the obtained results, different perspectives, and new insights for the users. The evaluation of the proposed framework has to consider the generate topics. Since we have a web application, the processing time is an important feature, so we allowed only 3 variations for the number of topics and number of words. We use 10, 20, or 30 words that describe a given topic. Besides the usability, the variations considered were the ones that brought the best results in terms of coherence and semantics. Another point of evaluation is the correlations performed. We performed a case study on Dutch researcher Marion Koopmans, a virologist specialist in molecular epidemiology at Erasmus University. Our correlation step found that 34% of the research is related to a topic that generally deals with virology, 22% to the immune system, and 14% to a topic about the socioeconomic effects of the pandemic. This proportion matches 2 alternative sources of information. First, a report by Nature with research through our reference in the understanding of COVID-19, and second, the researcher's description on her institutional page. Although Marion's research is mainly on virology, in a broader context, for example, the dataset as a whole, other authors have more work aligned with this topic, such as the Japanese researcher Hiroshi Nishiura. Here you can see Hiroshi Nishiura. The analysis performed on authors can be extended to these authors' research institution and the countries that host these institutions. So we have here China, United States, Italy, Netherlands, and others. In this work, we propose and present a framework for efficient, consistent, and automatic information extraction from a scientific dataset regarding COVID-19. And we believe that our analysis will be of great value to educational institutions and companies for the formation of multidisciplinary teams once the main research lines of research are identified based on their researchers. In addition, funding agencies can use our work to identify areas of research that are more or less explored. In future works, we intend to improve our application, ensuring greater interactivity and more visualizations besides submitting the steps described in this work in a different data set and name it to another area, such as computer science research, for example. We would like to thank the funding agencies that support in part the conduct of this research, CAPES and CNPq, and of course the Federal University of São João del Rei, my university. And if you have any technical question, please contact the main author, Antonio Pedro, our undergraduate student. Thank you.
Thank you, Diego. Bye. See you next time. So we can
Please stop sharing your screen.
Stop sharing my screen, okay.
Thank you.
How can I stop here? Share. I'm not able to stop sharing. How can I do it? I have never used Jitsi. It's the first time.
Maybe from the 3 dots on the bottom of the screen. You can
3 dots. No.
Leave the session and come back again.
I will enter again.
Okay. 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 Let's listen to the other paper.
Okay. I think.
Thank you, Diego.
Thank you. It's okay now. Okay.
Do you have any question?
Question?
Remember, any technical question, please ask to my student. They can answer some doubts.
Okay.
Okay.
Okay. Thank you, Diego.
Thank you. Thank you very much.
Bye. So we have the other paper who is going to talk about the second paper, using quadratic discriminant analysis by intrusion detection system for pore scan and slow loris attack classification. Is there somebody to speak about, to talk about this paper? Nobody? No? Let's we go to the next paper. Systematic literature review on services-oriented architecture modeling. And who is going to present? Nobody? Okay. And then the next one, a deep learning solution for integrated traffic control through automatically sensor plate recognition.
Hi,
Hi.
I'm Sebastian. I'm the last presenter of the last
Okay.
presentation. So if there are
Okay.
no the previous two, I can present now.
Okay. We can start with you, and next, if somebody arrived, they will talk after you.
Okay.
It's okay. The floor is yours.
Thank you.
Sebastian.
Okay, I share my screen. Can you see my slides?
No.
No,
No?
you have to choose your windows.
Okay, but I cannot see the window in the list of, sorry. Okay, now yes.
Okay.
Now can you see?
Yes. It's okay.
Okay, thank you. So I'm Sebastian Pod. I'm going to present a deep learning solution for integrated traffic control through automatic license plate recognition. So let me introduce the context in which this work falls. There are many applications nowadays that are taking advantages from the adoption of IoT networks in smart cities, and these include, but are not limited, for example, to biometrics, traffic light management, video surveillance, crowd analysis, and also many others. However, given the in the wild nature of the urban environment, these applications need to be tailored to the specific challenges of this context, of the context of smart cities. So our goal in this work was to design a deep learning solution for traffic surveillance in smart cities. This solution is composed by two layers. The first one to determine the risk level of the current traffic, and the second one to recognize license plate numbers of the vehicle involved in the traffic anomalies. In particular, the solution mainly exploits deep neural networks, so deep learning techniques for its whole pipeline. The system is currently part of a project, of a work in progress prototype. This is its main architecture. So we have a road level composed by so-called smart lampposts, which are street lampposts equipped with camera sensor for acquire the video stream, the live traffic video stream, and also a particular embedded board, which is the NVIDIA Jetson, that is responsible to run the deep learning software of our solution. So, as I thought before, our solution is composed by two modules. The first module is the risk estimation module, which is responsible of identifying anomalous traffic situation. What does this mean? This module analyzes the live traffic video stream and returns a probability P of abnormal events occurring in a certain time window. And this probability is called traffic risk estimation. So if this traffic risk estimation is greater than a certain threshold, then this module stores the associated video clip in the cloud. So essentially, this module acts like a filter. It discards the regular traffic flows and only focuses on abnormal traffic flows, so on anomalous traffic situation. To implement this module, first of all, in this work, we have defined a taxonomy of possible traffic anomalies that are interesting to detect with a deep learning solution with a video surveillance system of this type. And we divided these anomalies into categories. The categories of static anomalies, which are those ones that can be detected by analyzing only a single frame.
Sebastian, sorry,
See?
but your slides are not going on.
No,
It's just the introduction.
the introduce. I'm in the slide risk estimation module now.
No.
Okay.
We can see just the first.
And
With
now?
now, yes. Now it's okay. Thank you.
Okay, no, because I was in
You are
the
not
full
in
screen,
presentation mode.
no, I was in presentation mode, but probably you cannot see. Tell me if you now can see when I switch the slides.
The slides now are going on.
Okay, so this was the architecture. Now I'm presenting the risk estimation module. I was saying that we divided between static anomalies, which are those anomalies that can be detected from a single frame, and the dynamic anomalies, which are those ones that need to analyze different consequent frames. So in this work, we only focus on static anomalies, and to do so, we exploit a faster RCNN, which is a region proposal network, in this case based on ResNet, for example, to recognize anomalies like traffic congestions, some kinds of traffic collisions, vehicles, objects in the streets, and so on. For the identification of dynamic anomalies, we are still working on this, and we are now experimenting with YOLO and some heuristics. So to train this neural network used in this module to recognize the traffic anomalies, we have built an ad hoc dataset. Why? Because it's difficult on the web to find dataset that covers a large type of anomalies, and so we decided to generate some synthetic videos through the editor of the Rockstar GTA 5 game, so to simulate a very large number of possible traffic simulations. We have now something like 800 videos of different categories of anomalies, and we observed that this has a good trade-off between the realism of the simulated scene and the coverage of different types of anomalies. So we observed that in test, so testing both on the synthetic videos, but also in real-world live traffic video streams, the current implementation of this module shows good recall values, around 90%, but relatively low precision, because we are now focusing only on static anomalies, and this part is less powerful than the dynamic ones. But at this stage, this is good enough because, as I told before, this module is oriented to act as a filter, so to eliminate from the analysis the regular traffic flows, and only to highlight the high-risk traffic situation. So we want to reduce the false negatives, but it's not a problem if we have now some level of false positives. So switching to the second module, which is a license plate recognition module. This is responsible to automatically extrapolate the license plate numbers of the vehicle involved in high-risk traffic situations. So from those video clips extracted by the first module. In particular, this is one of the main contributions of this work, because we also defined a new algorithm of license plate recognition to be applied to this module. This algorithm uses YOLO, which is a kind of single shot detector, a neural network for the first level, to detect and isolate the license plate numbers. Then we perform some standard pre-processing with image processing techniques like the Kenny algorithm, auto method, some filters, and so on, to perform, for example, rotation, segmentation, blob rejection in the license plate images. And the last level of this algorithm exploits another deep neural network, in particular a long short-term memory from the library Tesseract, to perform the actual character recognition. So it is like an OCR system. This is the whole pipeline of this module. So there is the detection phase through YOLO, then the rotation and character segmentation through the standard image processing techniques. And finally, we obtain the binary images of the license plates and apply the OCR level, so the long short-term memory. This second module was tested on an hybrid dataset composed in part from video frames extracted from the first module, output, and in part from real-world traffic slash vehicles pictures downloaded from the well-known website PlateMania. We obtained an 87% of average accuracy, which is very good. Also, if compared to the competitors in literature, so it is in line or sometimes better than the competitors. And we observed that the main recognition errors we obtained was due to the reading errors, so to the last part of the pipeline, the LSTM, and this is due in particular to perspective distortions, or also character ambiguity. For example, pairs of character like the S and the 5, or the C and the G, and so on. So to reduce this problem, we decided to train different Tesseract, so different LSTM models, and to use them in a fusion fashion. So applying a majority voting on the prediction to take the final decision. Okay, so I have concluded. Thank you for your attention. If you have any question.
Thank you, Sebastian.
Okay.
Thank you. Are there
Thank
any
you.
questions or comments? Nobody? Very interesting work, Sebastian.
Thank you.
I work in the same in the topics of road infrastructure, and so traffic accident and so on are
Very close.
very interesting topics for me.
Okay, thank you.
Okay. Is there somebody for the other two presentations? Using a quadratic discriminant analysis by intrusion detection system for port scan as low risk attack classification. Or the other, systematic literature review on service-oriented architecture modeling. No? We can wait them until 4, sorry, and then we can close this session. Okay, nobody has arrived to talk about the two others papers. So we can close this session. I thank all the presenters and the attenders, and see you on ICSA and the other event. Bye bye.
Thank you. Bye.
Bye.
is on. is on.
Hi Beniamino, welcome.
Hi.
Angela is speaking.
Oh.
How are you?
Fine.
All your colleagues still missing you.
Okay. Do you know that that I'm in my room? No? Do you recognize my room?
Yeah.
Ma sta andando bene, ho capito. Ci sono stati problemi con YouTube stamattina, ma tutto sommato è andata, ho capito.
Sì, è andata, ha risolto tutto Damiano.
Ma giusto per qualche minuto sarà stato wow.
No, in realtà tutta la sessione mattutina sono stati in pochissimi a condividerla su YouTube.
Vabbè, diciamo, ce la facciamo alla fine.
C'è un'alta percentuale di persone che non si sono collegate in realtà.
Perché?
Non lo so, però io ho il 50% in questa stanza.
Di persone non collegate?
Sì.
Ma che proprio sparite totalmente?
Sì, ci hanno rinunciato proprio a presentare.
Vabbè, mi dispiace. Vabbè, la prima mattina, no? Speriamo che la cosa... Vabbè, erano pure sessioni quasi tutte di general track e altri casi.
Sì.
Quindi diciamo che è abbastanza... è diverso. Spero che ora la situazione sia la meglio. Comunque la plein air è bella, era bravo il tipo, bello, interessante.
Sì.
Il keynote era bravo.
L'abbiamo seguito in aula magna.
Ah, voi eravate in presenza, giustamente.
Sì.
Bella, sì, io l'ho seguita, in contemporanea tenevo un consiglio di facoltà. Basta il consiglio di facoltà e sentivo la cosa, interessante, molto bello. Questo l'ho trovato vivo, bravo. Un po' filosofo, però bravo. Domani mattina ci sta quello sulla salute che ha trovato Bob, che deve essere bravo pure.
Sì, l'altro keynote.
Bello, questo è arrivato... Secondo me è interessante pure questo qua. Vabbè, dai, questo va
I
bene.
relatori di oggi li conosci?
Chi? No, nessuno. Questi qua sono general track, sono informatici pure.
Ok. Vabbè, vediamo.
No, mi hanno infilato mo', me ne sono accorto oggi pomeriggio. Ma tu hai scritto pure University of Potenza pure.
Poi ci danno dei campanilisti.
Chi se ne frega. Senti, ma siamo solo io e te qua dentro, questi altri chi sono? Scusa, non si capisce.
Non lo so, però non si sono registrati. Alcuni c'erano già dalla sessione precedente.
Quindi non sono di questi qua, secondo te?
Non lo so.
C'è pure Lucia per te.
Ciao.
Tu hai finito la tua sessione?
Sì, sono libera di pomeriggio.
Ah, non c'hai sessione?
No.
Ok. E quindi pensavo che andassi da Sangiai a divertirti. No, vabbè, ci sono cose sicuramente interessanti, immagino. Ci saranno comunque... Ma c'è anche una sessione di Chiara, quest'altro sulle Island che ha fatto qualcosa, giuro.
Sì, sì. Ti mandano i saluti Giuseppe, Sabrina, Eufemia, Chiara. Chi abbiamo incontrato più? Francesco Rotondo.
Vabbè, mi dispiace. Com'è il B&B? È buono?
Sì, è molto carino.
Me l'avevano detto che...
Poco luminoso,
Allora,
però per quello che ci serve. Ed è al centro della Movida, quindi anche strategico.
vabbè. No, questo me l'aveva detto Sabrina, che è un'amica di cosa? Di Ginevra, che mi ha segnalato il coso. Quindi deve essere...
Ok.
Someone of the speaker of the next session are in the room.
Hello.
Hello.
I'm Farah. I'm the first presenter.
The first presenter means
Yes.
Farah Abmezeyem.
Yes, exactly.
I pronounced in a terrible way, but I'll try to improve for the official presentation. Okay.
Yes, thank you. It's Abdemezia.
Okay. Okay, and just one? No more? No more? No more speakers? Okay, if you are alone, this means that you have all time for you. You can speak 1 hour and we can do questions for another hour.
Okay.
Okay?
Good for me.
If you have the voice for this time, for us it's okay.
I can start?
No, we can wait.
Okay.
Particularly if you are alone, we can wait other 10 minutes in order to hope that someone else will join to the session.
Okay, perfect.
Beniamino, I remind you to fill in the form for the evaluation.
Yes. Yes, I know. I sent yesterday night the evaluation form to the workshop organizers. This means that this means that I hope that just one, not just one, but I hope. In this case, the rate is lower than 50%, Angel.
Yes.
53%. Okay. If you are in face-to-face conference, in this case, it's better because you can move the speaker in another room with where someone is missing, and you can have a better session. Just writing on the blackboard in the room that the session has been moved in another room. But in this case, with online conference, it's not possible. You have to stay. Otherwise, we can join with another, I don't know, another general track. And,
yes.
would be more interesting in this case. No one has been joined? No.
I think not.
But who are the other fellow Gister? Okay, no. I haven't asked to. No, you are not speaker in this session. No. No. No more speaker in the session. Okay. We can wait other 5 minutes just for. Okay, no one else joined. In my opinion, we can start. It's time to
Okay.
start. Just 7 minutes of delay. Obviously, if someone else and other authors will join at this session, will be welcome, and we'll consider at the end of the first presentation. Okay. Welcome to the general track 5.5. At this time, we have just one speaker. I hope that the other will join in short time or during the first presentation. The title of presentation is on data security of information systems, comparison of approaches and challenges. 3 authors. In this case, will be presented. The paper will be presented by Farah Abdelmedziem, University of Science and Technology, War Boumediene. There are also other 2 colleagues from the University of Nantes at the same university. Okay. In this case, theoretically you have just 10 minutes for another 5 for questions, but in this case you can stay relaxed because you can have your time for your presentation. Okay.
Okay, perfect. So let me just share my screen. Okay, can you see my screen?
Yes, perfect.
Okay, perfect. So have you ever been in the situations where your organization or company's computer system was the target of cyber attack? If you didn't, well, you've just missed a panic situation. In fact, it is quite legitimate to panic because this organization or companies in this case are putting their reputation at stake and losing a lot of money. And indeed, according to Forbes, every minute more than $2 million is lost to cybercrime, and this is just so huge. My name is Farah Abdelmedziem, and I'm a PhD student in information system security, and my research goal is to avoid those panic situations. So today I'm going to present to you my survey paper on information system security, specifically on the data security of information systems. So I will begin by giving you some background information about the 3 layers that constitute an information system architecture, followed by our first meta model that will link information system elements with the security. Like I said earlier, we focused on the data layer of an information system. So at this point, I will present to you a second meta model that will detail the elements of this layer. Then I will present to you an overview of the proposed security mechanisms to ensure data security. At this point, I will sum up my my results through our third and final data security meta model. I will show you also how we use our meta models to compare the research approaches in the literature and to put forward the research challenges. So let me begin by a brief definition of IS. So IS is for information system. So IS is defined as a set of resources where data is gathered, processed, and transmitted between the different actors of an organization. Besides, we have the information system architecture that is composed of 3 main layers. So first, we have the data layer that represent the main types of data that support the company's activities. We also have the application layer that defines the applications needed for data management and business support. And finally, the technology layer that represents the main technologies used to implement the data and the application layers. So before jumping into more details into the data layer, let me give you a holistic view of the information system elements and security through our first meta model. So this meta model is composed of three main parts. The first part, where we find the IS layers. The security part, where security is defined through three main goals, namely confidentiality, integrity, and availability. So let me pause here to give you a brief definition of these goals. Confidentiality is the assurance that the IS assets are kept secret. The integrity is the inability to alter these IS assets. And the availability is the ability to access the IS assets whenever it is needed. So to ensure this security and to mitigate the security issues faced by the three layers of an IS, security mechanisms are proposed. These mechanisms are supported by tools or frameworks and have impact on IS non-functional properties. So I will detail these properties later. Turning our attention now to the data layer and its element. So data can be of different types, mainly structured or unstructured. It is stored and processed into databases that could be SQL or non-SQL databases. These databases can be deployed on premises or in cloud environment. So when data with its different type is with high volume and velocity, we talk about big data. Finally, data can be at two states, at rest or in motion. So regarding our survey, we studied 28 research work in total, and this table gives the year range of the surveyed paper according to each security goal. Let's move on now to the security mechanisms that we classified in this table. So for the confidentiality, we distinguished three mechanisms. We have access control, anonymization, and encryption. For the integrity, we have the mirroring mechanism, the checksum mechanism and its application through digital signature, and the use of the blockchain technology. Finally, regarding the availability, we've selected the backup and recovery mechanism. So here's a brief definition of this mechanism that I could detail later for those who might be interested. We come now to our third and final meta model, the data security meta model, where we find the data object that I detailed later, the security aspects or goals, and the proposed security mechanisms propose to meet each security goal. At this point, I'd like to elaborate further the non-functional property part. So in our work, we've selected four non-functional properties. First, we have the management of the security solution that states if the proposed security mechanism is easily applicable and maintainable. We also have the data transmission time that refers to the response time for data access requests, especially in the case of big data. Moreover, it is also important to evaluate the security solution with regard to monetary cost and the computational burden induced by the implemented security mechanism. So we used our three meta models to compare the research work. We presented three tables that tackled respectively data confidentiality, integrity, and availability. And here's a glimpse of one of these tables that tackle the approaches in the case of data confidentiality. And you can see here that we used the element of our meta models to compare the approaches. We find then the data types tackled by the security solution. We have the security mechanism in question, whether it is access control, anonymization, etc. We have the technology tackled by the solution to see whether it's for data that is stored on on-premises databases or in cloud environment. We also find the tool framework column that specify if the proposed solution gives implementation details. And finally, we criticize the approaches according to our non-functional properties in the drawback column. So from our comparison tables, we've come to the following conclusion. First, regarding the security goals. So we've noticed that generally the proposed approaches don't consider the 3 security goals at once. So hybrid approaches that combine 2 or more security mechanisms could be investigated. Then regarding the encryption mechanisms. So here also the proposed approaches don't give much attention to the management and the security of the cryptographic keys, as this later could be the target of security attacks. Now, for data type plays a crucial role when it comes to choosing the right security solution. Indeed, you can find a security solution that gives a satisfying result when it comes to structured data, but present performance issues and computational burden when dealing with big data. For big data security, so the proposed solutions are still not mature compared to structured data. Hence, this field lacks standard tools and models. Finally, the proposed security mechanisms and frameworks should be as dynamic as possible to cope with environmental and data changes. In conclusion, let me sum up my main points. So security is one of the most important properties of information systems. In our work, we focused on the security of the data layer, and we put forward data security meta models that we use to compare the research works in the literature and to identify open challenges in these fields. As future work, we intend to present our meta models to professionals in order to evaluate the trade-off of each security solution. We are currently working on this meta model and its application on the e-health domain in cloud context. And finally, we are about to propose another meta model that covers the security of the application layer. Our ultimate goal being to propose a generic meta model to be used as a reference to secure the 3 layers of an IS. Thank you for your attention, and now I'm happy to answer any question you may have.
Thank you, Farad, for your very interesting presentation. Question from other attending people? Okay, meanwhile, I have just a question. Have you considered the percentage of the increase of the rate of the increase of the security, considering your model, in order to have an assessment of how much it can be improved adopting this model? This architecture model.
Sorry, I didn't hear the last part.
Have you assessed the rate, the percentage of the improvement of the security of the system, considering your proposed architecture?
So regarding the proposed solution in the literature?
Yes.
No, unfortunately, if we do that, so we'd have to implement all the proposed solution, and we just couldn't do that.
Yes.
So we gave our.
Okay, continue. Sorry. You can continue. Sorry.
Yes, so we just gave our interpretation of the solution and our point of view, if you want. We couldn't implement all the security solution. There were some papers where the author presented the evaluation part, so the conclusion was straightforward. And for the other papers, we just analyze the proposed solution and try to see how the security solution could react in case, for example, of big data.
Yes, yes, but if you have designed something, no? Considering this, normally if you have to convince someone to develop, to financing your idea, probably it could be better that you can say, okay, we can improve this of 20% thanks to this new architecture, just for having some number. Just that was my
yes,
my question, no? And
yes, I totally agree with you. Sorry. Yes, continue. Sorry.
Yes, no, but okay, I'm not completely convinced about the idea of big data. Probably more than cloud computing than big data, because big data means everything. Also, you can also, if you classify images, satellite images is big data. Also, spatial statistics is big data. Probably it does not need about security, but the cloud computing is really the something useful new architecture and security, because okay, if I use a system for my analysis with online analysis, it would be better. It's just my opinion. Okay.
Okay.
You can answer other comment. It's my idea, but probably you are not agree with me. You can continue if you want.
Yeah, just for your remarks when you said that we should consider the percentage of the
yes.
Yes. So, like I said in our future work, we are currently working on this validation of this meta model in the case of e-health. So, the sensitive data in the e-health domain. So here we can propose what you actually said, the percentage, and we can claim that okay, with this solution the security or the performance are improving or not. Okay. So it's one of our future work.
Okay, thank you so much.
You're welcome.
Other questions? No more questions. Other speakers? No? This means I consider closed this session, and we have time just for joining another interesting session. There are a lot of parallel sessions. I invite you to participate to this other session. Okay, have a good afternoon, and continue to stay tuned with the conference.
Thank you.
Okay. Hi, Angela. Hi, Lucia. I will come to other session. Bye. Bye.
Bye.